Today we're going to be discussing the counting rules using combinations and permutations. Example number 1, we are given a password which would consist of 2 digits and 2 letters of the alphabet. The question is, part A, how many possibilities of passwords we can have if repetition is allowed? We have 10 different options for digits we can choose from for the first slot, because your numbers are going to be ranging from 0 to 9, so that's 10 different options. We can repeat the same digit we placed in the first slot, so we have 10 options to choose from. For the letters of the alphabet, we have 26 possibilities. Since repetition can be allowed, we're going to have 26 different options for a letter of the alphabet to pick from. So when we're going to multiply 10 times 10, 26 times 26, we're going to end up with 67,600 possibilities of passwords. Part B, repetition is not allowed. We have 10 options for the digit to choose from, but whatever digit we pick for the first slot cannot be chosen for the second slot, so that will leave us 9 possibilities. 26 letters of the alphabet for slot number 3. Since whatever letter of the alphabet we choose here, we cannot repeat it, so that will leave us with 25 options to choose from. We're going to multiply 10 times 9 times 26 times 25. We're going to end up with 58,500 different possibilities. Example number 2. We have 4 models of phones to choose from. We have 6 colors, and we have 5 calling plans. The question is, how many combinations of phones we can select with these conditions? So we're going to take 4 multiplied by 6 multiplied by 5. That's how we again apply what we call the counting rule. And 4 times 6 times 5 will give us 120 possible combinations of phones to choose from. Example number 3, we are given a problem where we have a 4-letter call letters. We are given that the first letter can be a W or a K, and others can be letters of the alphabet as well. The question is, how many combinations of 4-letter call letters we can have if repetition is allowed and if repetition is not allowed. So if repetition is allowed, we have 2 options to choose from for the call letter. It could be a W or a K, so that's 2 possibilities to choose from. Since repetition is allowed, whatever letter we choose, a W or a K, since it can be repeated, that will give us 26 different options. Since the other letters are also letters of the alphabet, then we can choose 26 and 26. So we multiply 2 times 26 times 26 and 26. We'll end up with 35,152 possibilities. Part B, repetition is not going to be allowed. So we have, again, 2 choices for the first slot. Could be a W or a K. Whatever letter we choose, a W or a K, since it cannot be repeated, that will leave us with 25 options. Whatever letter I've chosen for the second slot, it cannot be repeated, so that will leave me 24 options. And for the fourth slot, it's going to be 23. So we're going to multiply 2 times 25 times 4 to 23. We're going to end up with 27,600 possibilities. Example number 4. We're going to define what the permutation of a number is. So we're going to say NPR. This is the number of permutations. n objects. Chosen r objects at a time. I have posted for you how to use on a TI-30XA calculator the permutation button. So these, for example, for permutation 3, we have a total of 4 objects. We're going to choose 3 at a time. So that will leave us the value 24. So please refer to your link for a video of how to effect the permutation function on your calculator. Example number 5, we are given a total of 7 tests. We want to choose 3 tests at a time. The reason we're going to be using a permutation because the order is important in terms of how we pick 3 tests out of 7. So on your calculators, 7 permutation 3 will give us 210 possibilities to make a test where it's selected out of 7 total. Example number 6. We have 7 federal agents. We want to choose 5 at a time. And the reason we're using a permutation as a function to affect the calculation because the order in which these agents are going to be chosen, the order is important because different agents can have different ranking. So on your calculator, 7 permutation 5 will give us the value 2,520 different agents so that we can select 5 out of 7 total. In the following example, we're going to look at example number 6 or 7.
7.
Example number 7. We have 11 movies. We want to select 4 at a time. The order is not important. We're going to choose 4 movies out of 11 because the movies that we're going to choose 4 at a time, considering the order is not important, this is not going to be a permutation problem. This is going to be what we call a combination problem. So on your calculator, we're going to effect an 11 combination 4 instead of 11 permutation 4. And 11 combination 4 on the calculator will give us 330 movies. We can select 4 out of 11. Example number 8. They're asking us how many ways, if we have out of a total of 52 cards in a deck, can we select 3 cards at a time? This is a combination problem because it does not matter how we select our 3 cards. The order is not important. The arrangement is not important. So it's a combination instead of a permutation. So 52 combination 3 on your calculator will give us 22,100 different possibilities. Example number 9. We are given 12 basketball players. And we are given from these 12 basketball players, we want to select 4 at a time. And we are given 9 baseball players from whom we want to select 3 at a time. The question is, how many combination of players we can select such that 4 are going to be chosen out of 12 and 3 are going to be selected out of 9. So the way we're going to calculate this is we are going to take 12 basketball players from whom we want to select 4 at a time. The order is not important how we pick the players. We're going to multiply that by 9 baseball players from whom we want to select 3 at a time. So on your calculator, what I would like for you to do is to calculate 12 combination 4, and whatever the outcome is, I'd like for you to multiply it by 9 combination 3, and that's how we're going to select the 7 players out of total of 21 players altogether. Example number 10, we're going to be stocking a candy machine. So we're given 6 candy bars from which we want to select those out of list of 10, and we are given 6 salty snacks to select out of list of 12. So the question is, how are we going to stock the vending machine selecting 6 candy bars out of 10 and 6 salty snacks out of 12? We're going to do this just like the previous example. So for the candy bars, it's going to be a 10 combination 6, which should give us the value of 210. And for the salty snacks, it's going to be 12 total, from which we're selecting 6 at a time, for which we're going to end up with a value 924. Just like the last problem, finally what we're going to do is we're going to multiply the outcome of these two. So 10 combination 6 times 12 combination 6, it will be the numbers here, 210 multiplied by 924, and that's how we're going to end up with a total of 194,040 different combinations we are going to stock the vending machine.